Hey guys, so officially today we're learning something new this year. So far all we've found are real solutions. Today we're going to find solutions that they're not considered real because they're not real numbers. So what we're going to find are like solutions of quadratic equations, even though they don't appear like solutions. So like when you graph them, they don't cross your x-axis, so you don't have any zeros. But they still have solutions of the equation. So our objectives are to answer the question, what are complex numbers? We're going to identify and perform operations with these numbers, and then we're going to find complex solutions of quadratic functions. So we're going to get into something new. I hope you're all excited. I like complex numbers, and I hope you will too. So the imaginary unit I is a complex number whose square root is -1. So I squared is -1, and I is the square root of -1. So if you have, in your quadratic form, your b squared minus 4ac under the square root, if it's negative, it's not a real solution because we can't have square roots of negative numbers, but we can have square roots of what we call imaginary numbers. An imaginary number is any number in the form a plus bi, where a and b are real numbers. You can write a complex number in the form a plus bi. If a equals 0 and b does not equal 0, the number a plus bi is a pure imaginary number. In the complex number plane, we're not going to graph these just because it gets pretty complicated and it's going to be really hard for me to show you. But the point AB represents a plus bi. The absolute value is its distance from the origin, or still from 0. So the absolute value of a plus bi is the square root of a squared plus b squared. And a plus bi and a minus bi are complex conjugates. If you have an imaginary number in the denominator, in order to get rid of it, you have to multiply by its complex conjugate. Okay, so let's do some stuff. Simplifying using I. How do you write the square root of -18 by using the imaginary unit I? Okay, so if I have the square root of -18, I can simplify this. Square root of -18. So I need to know what number is a factor of 18 that's also a perfect square. Well, I have -1 times 2 times 9. 9 is a perfect square, right? So I'm going to take and I'm going to put -1 times 9 in one box, and -2, or a square root of 2, in another one. The square root of 9 is 3. The square root of -1 is I square root of 2. So 3i square root of 2 is the square root of -18 simplified. Isn't this fun? It's like a whole new thing that you didn't know existed, but now that you know, it's like, whoa, this really exists, and it's super cool. Okay, so let's do the negative square root of the square root of -12. Oops, my apologies. Okay, so square root of -12. What are my factors that are perfect squares inside 12? I'll have -1 times 3 times 4, right? -1 times 4 times square root of 3, so that's 2i square root of 3. Answer. Oh, these are so fantastic. Come on, catch up. I'm sorry, my technology is being really slow. Okay, what's the square root of -25? That would be 5i. What about the square root of -7? Can we simplify the square root of 7? We cannot. So this would be I square root of 7 in order to have it in its proper form. Alright, next we're going to be adding and subtracting complex numbers. So just like when we have variables, you can only add like terms. So let's find each sum or difference. If I have 4 minus 3i plus -4 plus 3i, I combine my like terms. So I have 4 plus -4 and -3i plus positive 3i. So 4 plus -4 is 0. -3i plus I is 0. So this would be 0. Well, that wasn't very difficult. Okay, what about this one? Okay, do you remember when we subtracted, I don't know, what was this, Algebra 1? In order to subtract, you change signs. So 5 minus 3i plus 2 minus 4i. Combine my like terms. 5 and 2 makes 7. And negative 3i, negative 4i makes negative 7i. So 7 minus 7i. 7 minus 2i plus negative 3 plus I. See, that makes 4 minus I. What about this one? Are we doing okay with these? Pretty easy? Okay, good. Now we're going to multiply complex numbers. So we're going to take it one step further instead of just adding and subtracting, because we know we can multiply any numbers. So we're going to multiply 3i times the quantity, negative 5 plus 2i. So first I'm going to do 3i times 5 plus 3i times 2i. Okay, 3i plus, or times 5 is, 3 times 5 is 15i. Okay, and then 3i times 2i. 3 times 2 is 6. And then we have I squared. Now do you remember from vocabulary, I squared, what does that equal? Negative 1. So this becomes 15i minus 1. But in order to put it in our correct a plus bi form, we have to switch these around. So negative 1 plus 15i is the most correct form of your answer. Oops, that should be 6. 6. Negative 6 plus 15i. Most correct form of your answer. Okay, what about this one? We multiply binomials. What do we have to do? We have to FOIL. Is everybody so excited for foiling? I love foiling. I also love fall. So I picked orange. FOIL. First, outer, inner, last. So first is 4 times negative 1. That's negative 4. Outer is 4 times negative 2i. That's negative 8i. Inner is 3 times negative 1. Negative 3i. And last is 3i times negative 2i. That's negative 6i squared. Okay, we know this negative 6i squared is going to become a positive 6. So we combine our like terms. Number goes first. 6 and negative 4 is 2. And then put these minus 11i. 2 minus 11i. How you feeling? You like eyes? Eyes are cool. I like imaginary numbers. I don't know. It's kind of like solving, doing the systems of equations. Like, I feel the same on the inside right now. Okay, let's go ahead and multiply these. Negative 6 times 6 is 36. And I have plus 6i minus 6i minus I squared. So those cancel. This becomes a plus 1. So my answer is 37. Oh, and that one, 7 times 3 is 21, I squared, make it negative. Negative 21, I squared. Okay, go ahead and do these two, and then I'll throw up the answers really quick, because these are fun, and you've got it. Alright, so I went ahead and left my work up here so you could see it. So I got 23 minus 2i for the first one, and 41 for the second one. Go ahead and check your work, and check my work, because, you know, I make mistakes too. Just, shh, don't tell anyone. Alright, dividing complex numbers. So we're going to find quotients now. So I have 9 plus 12i, all divided by 3i. Now, we don't like to have i's in the denominator. So what we're going to do is we're going to multiply by the inverse because we want it to be positive. So we're going to multiply by, here, let me rewrite it this way. 9 plus 12i. I suppose I don't need parentheses, over 3i. We're going to multiply that times negative 3i over negative 3i, which means we're multiplying by 1, so we're just changing the form. Because when we multiply the bottom, we get negative 9i squared, which becomes positive 9. And then in the top, we multiply here and here, so we have negative 18i minus 36i squared. That becomes plus 36. So that's 36 minus 18i over 9. Now, these are all reducible by 9, so we can just divide each one. So let's see, 36 divided by 9 is 4 minus 2i. And this is your answer, ladies and gentlemen. Okay, so what about this one? We're going to have to use our complex conjugate, not just the opposite for this one. So let me rewrite this. Grab another fun color. How about purple? 2 plus 3i over 1 minus 4i. Now, we're going to multiply by its complex conjugate. So if you remember from our vocabulary, that's the same thing, but with an addition sign in between. Okay, and then we need to FOIL the top and FOIL the bottom. So let's go ahead and start by just doing the top. So 2 times 1 is 2. Outer is plus 8i. Inner is plus 3i. Last is plus 12i squared, which becomes minus 12. So on the top we have negative 10 plus 11i. Okay, now for the bottom. Let me go ahead and grab another color. For the bottom, we're going to multiply this one. 1 times 1 is 1. Outer is plus 4i. Inner is minus 4i. And then we have minus 16i squared, which becomes plus 16. And these cancel. So this is why this is super important. Over 17. So negative 10 plus 11i over 17. And there you have it. So for this one, 5 minus 2i over 3 plus 4i. What are you going to multiply by? What's your complex conjugate going to be in order to get rid of this I in the denominator? We're going to multiply by 3 minus 4i. Okay, and then use your FOIL, simplify, get into its most simplest terms. And then this one we multiply by negative 6i, so we get a positive number. And lastly, we're going to find imaginary solutions. So not just using those complex conjugates or complex numbers, but also using it to find solutions when they don't exist. So we're going to use the quadratic formula just like we normally would. So we get, when you simplify, okay, well, let's just take it one step at a time. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So a is 2, b is negative 3, and c is 5. So x equals 3 plus or minus the square root of negative 3 squared minus 4 times 2 times 5 all over 2 times 2. Okay, so let's take this and simplify this. It's 3 plus or minus the square root of 9. Let's see, that's minus 40 over 4. 9 minus 40 is negative 31 over 4. Now we can't simplify the square root of negative 31, so I'm going to write it as my solutions are 3 plus or minus I square root of 31 over 4. And this would be our solution. So this doesn't actually cross the x-axis, but it is a solution. Alright, these also are going to be the same thing, so just, plug away with that quadratic formula, you're going to get it. And here's your lesson check. Answer these 3 questions, bring them to class, and talk about them with your partner first thing tomorrow before you start your worksheet, and make sure you behave for Mrs. Tassie. Okay, and also your homework is Math Excel Lesson 4.8. and I'll see you at the end of class tomorrow.